Okay, so the start of chapter 2, we're going to be talking about how to solve linear equations. And so just to get started with a quick review of an equation versus an expression. And these are two things that we've seen before. We saw some examples before where you had to identify if it was an equation or an expression. Just to review that, an equation looks something like x minus 5 equals 2. And so it has to have this equal sign here. If it doesn't have an equal sign, so let's say we just have x minus 5, then this is an expression, and an expression we can't solve. We can't find what x is. Can't find what it's equal to because there's no equal to sign. And so now let's go ahead and take a look at what our linear equations are going to look like. And we're looking at linear equations in one variable. So we're just looking at the case where we just have an x or some other variable, but we're not going to look at the equations where we have an x and a y quite yet. And so standard form of a linear equation in one variable is going to be ax plus b equals c. And so a, b, and c are going to be real numbers. And so that's just any of our numbers that we've been working with. We're just not working with those imaginary numbers. And so it can look anything like this one that we saw up here. It could also look like x equals 5. So this is the case where it's already solved. But this is still a linear equation. Or we could have something like 2x plus 3 equals 4. But notice how none of these, or neither of these two x's have exponents. And so if they do, we call those non-linear equations. So just so you have a couple of examples of those, x squared plus 2x equals 0 is nonlinear because of this exponent right here. Same thing if we had x cubed equal -1, still have an x cubed, so it's nonlinear. 1 over x equals 6. This one doesn't look nonlinear because it's an x, but because it's on the bottom of a fraction, if we were to move it to the top, this would actually look like x to the -1st, which we'll see a little bit later, but just know that the x can't be on the bottom of a fraction for it to be linear. And lastly, let's say we had the absolute value of 2x plus 6 equals 4. If we have this because the x is in between absolute value symbols, this is nonlinear. And so what you're basically just looking for here is just an x. You can add and subtract and multiply with it, but you can't have exponents on the x, and it can't be in a fraction or in absolute value symbols. All right, so now the solution for a linear equation in one variable is the number that makes the equation true. Oops. And so what we're going to do in order to find the solution is we're going to solve it by finding what we call the solution set. And so what you'll notice in the homework is they'll write their answers as a set, so with curly brackets, and they'll just put whatever the solution is in between, just the number, not the x equals. We'll see what that looks like, but you don't have to do that in the future, depending on what your professor requires. If you end up taking Math 96 with me, for example, you don't have to write your solutions like this, but it will show up like this on the homework. What it'll normally look like is x equals some number, or some number equals x. It can end up on either side. Just make sure that the x is by itself. All right, and one last definition before we can take a look at some examples. The addition property of equality. So this is what this entire section's about. And this is the first property we need in order to start solving equations. And so what the addition property of equality says is that if we have a true statement, A equals B, that means that if A is 4, B also has to be 4. And A plus C equals B plus C. If we have both of these, then we know that these are equivalent. And so that's just because we're adding the same thing to both sides of the equation. So let's say we had 2 equals 2. If I add 3 to both sides of the equation, we still have a true statement. We still have 5 equals 5. So it looks a little different, but it's still an equality. It's still true. And so you want to think of this as balancing the scales. So if you have a set of scales and you need to make sure they're balanced, if you add something to one side, you can't not add something to the other side, otherwise it would tip. All right, now we're just going to go ahead and run through a bunch of examples. And again, after watching a few, if you want to pause while I go through, try solving it. So I'm not really going to pause during the video, so I think that's a really good thing for you guys to do, just to make sure you're kind of getting it down by yourself. All right, so for these examples, we're just told to solve. And so this first one we're given x minus 12 equals 9. And so our goal is to get this x by itself. And so we need to get rid of whatever else isn't included in this x. And so we only have this minus 12. So this is where our opposites come into play. And so in order to get 0 here, we want to do the opposite of what we see. So since it's minus 12, we're going to add 12. What we do to one side, we have to do to the other. Negative 12 and 12 give us 0. So those cancel out, just left with an x. And then 9 plus 12 is 21. And so that's all we have to do for this one. To write this as a solution set, you're just going to put 21 inside curly brackets. I'll also go ahead and show the check on this one. So checking is a really good thing to do, especially on longer problems where there's a lot of stuff going on, just so that you don't, you know that you got the answer correct, and that if there's a lot of steps, there's a lot of places to mess up. Ones like these, not so much. But for the check, all we're going to do is take this 21, plug it back in for x into the original equation before you do anything. So 21 minus 12 equals 9. 21 minus 12 is 9, so this is good. Number 2, x minus 25 equals negative 18. So again, we want to get this x by itself. So we want to get rid of a minus 25. The opposite is addition, so we're going to add 25 to both sides. So left side, those cancel out, we get x. The right side, negative 18 plus 25, they're opposite, so we subtract and we get 7, and it is positive. So x equals 7. And I'm going to go ahead and just write the answer like this, because this is perfectly acceptable. Just know that you could also write it as 7 in curly brackets. All right, number 3, a minus 4.1 equals 6.3. Same thing with negative or decimals here. We have this a we want to get by itself and a minus 4.1, so we're going to do the opposite and add. 4.1. And I'm going to line these up so we can just add straight down. So we get 10.4. These guys cancel out. That's what our A is equal to. So for the most part, these first ones here aren't going to be too bad. The next section's where we're going to bring in the division and multiplication. So one good, nice property that makes solving some of these a little bit easier is when you have negative x equals a. So sometimes you're going to end up with a negative x instead of a positive x, but we always want the x completely by itself. So all we have to do is if you change the sign of the left side, you have to change the sign of the right. So this is the same thing as x equals negative a. And that'll come into play again when we see the multiplication property of equality in the next section. All right, number 4. Negative 15 equals b plus 12. So in this one, the b is on the right side, but that's perfectly fine. We still want to get it by itself. We have a plus 12 next to it. We want to get rid of the plus 12, so we're going to do the opposite and subtract 12. So on the right, these cancel. We're left with b. And now we have two negatives here. So we're going to add them. We get 27, and it's negative, so it stays negative. And you can go ahead and just leave it like this. You don't have to switch those around. So all of these we've been adding or subtracting numbers from both sides, but what if we have something like this? 11z minus 9 equals 12z. So if you notice with this one, we have two z's here, so we want to get all of the z's on one side, and then we want all of the numbers on one side. So there's only one constant term here on the left. I'm going to keep it on the left because if I move it over to the right, I can't combine it with this 12z because they're not like terms. So I'm going to move this 11z over. So remember, we want the opposite, so it's a positive 11z. So we're going to subtract 11z. And because we're adding and subtracting it, you have to do both the 11 and the z at the same time. They're kind of a package deal here. So those cancel, but on the left, we still have a negative 9. Make sure you don't lose any signs. And then 12z minus 11z gives us 1z, which is just z. All right, let's go ahead and try one where we use our negative rule that we talked about up here. If we ended up with negative x equals 6, to find out what positive x is, all we're going to do is we're going to take the opposite of both sides. So if negative x becomes x, 6 becomes negative 6. All right, this next one is a little messier just because we have fractions. Let's go ahead and write it down. So 7 over 2m plus 1 equals 9 over 2m. So again, we only have one constant term on the left side, so we want to go ahead and leave that one on the left. So I'm going to move this 7 over 2m over to the right side, and it's positive, so we're going to subtract 7 over 2m, subtract 7 over 2m. These cancel. We're left with a positive 1, so just 1. And then if I take 9 over 2 and subtract 7 over 2, they already gave us common denominators, so 9 minus 7 is 2 over 2, and 2 over 2 is just 1. So we're left with 1m, which is just the same thing as m. So I'm just going to say 1 equals m. All right, let's go ahead and try some multi-step equations. So all the ones that we just did are considered one-step equations because all we had to do was add or subtract one thing, and m was already by itself. These next ones are called multi-step because you have to do multiple things. So let's go ahead and try some examples here. And again, we're just told to solve. Notice how with equations we're told to solve expressions, we were only told to simplify. So number one, we're given 10 minus a equals negative 2a plus 9. And so this we have constants on the left and the right and variables on the left and the right. So we want to get the variables on one side and the numbers on the other. Doesn't matter which side you go to. If you can try to get it onto a side, onto the left side, it's going to be a little bit nicer for later on in this class where we talk about inequalities. So I'm going to go ahead and move everything to the left. I'll do it with the variables first. We have a negative 2a. To get rid of this, we need to add 2a, so we have opposites. And notice how you're only doing it twice because we have two sides of an equation. We can only add it to like terms. So this 10 just kind of stays out in front. Negative 1a plus 2 gives us 1. So plus a, or plus 1a, equals positive 9. And now we want to move this 10 over to the right. So it's positive 10, so we subtract 10. And we're left with a. And then 9 minus 10, they're opposite, so we subtract, take the sign of the larger number. So a equals negative 1. All right, number 2. And let me make a quick note here, actually, before we start number 2. Before you start moving all the terms around, you always want to make sure that everything is simplified first. And the reason for this is just that it's going to make solving a little bit faster, because if you have 7 or 8 terms on each side, you're going to be moving things around a lot. So we want to get it down to as few terms as possible. So number 2, we have 9r plus 4r plus 6 minus 2 equals 9r plus 4 plus 3r. So if we were to not simplify first, we'd have to move all of these r's to one side, move the numbers to the other, and that's going to take 3 or 4 steps just for that. We can go ahead and simplify first by thinking of each side of the equation as their own expressions. And so I'm going to combine like terms on the left side. So I could combine my r's and the 6 and the negative 2. So we get 13r, and 6 minus 2 is positive 4. And then on the right side, we can only combine 9r and 3r to give us 12r, but we still have a plus 4. And now it's just like this one we did up here, so we can go ahead and start moving the variables to one side, numbers to the other. So again, I'm going to move the variables to the left first. So we have a positive 12r, so we'll subtract 12r. 13 minus 12 is 1r. Bring down everything else, so plus 4. On the right side, we're left with positive 4. I said 4 and wrote an r. Oh well, I did that on the left side too. All right, sorry, on the left side is r plus 4 equals 4. And then we'll get rid of this plus 4, so the r is by itself. So plus 4, so I'll do the opposite and subtract 4. And cancel on the left. They cancel on the right as well, but I can't just leave a blank space. So 4 minus 4 is 0. All right, let's go ahead and try another one where we're simplifying, but the simplifying is a little different. So this next one, we're given 3 parentheses, 2x minus 1 minus 5x equals 8. So now notice that this one, the right side doesn't have anything to simplify, so we don't have to worry about that for right now. On the left side, we have to simplify, and remember, first thing you always want to do is clear the parentheses. So we want to distribute in this 3, and then we'll combine our like terms. So 3 times 2x gives us 6x. 3 times negative 1 is negative 3. Remember to keep your signs straight with these. And then this doesn't get distributed to this guy over here, so we still have minus 5x equals 8. And we're not done simplifying. Let's go ahead and combine like terms. So 6x minus 5x is 1x. Still have a minus 3 equals 8. And then finally, we can go ahead and get that x by itself, and we just want to go ahead and add this 3 to both sides. So we get x equals 11. All right, and then one last one here. Let's go ahead and try one more where we're simplifying. So we have 2 parentheses 5 plus 2m and parentheses minus 3 parentheses m minus 4 equals 29. All right, so let's go ahead and start distributing first. So 2 times 5 is 10. 2 times 2m is positive 4m. Now with this next one, make sure you're distributing in a negative 3. So negative 3 times m, negative 3m. Negative 3 times negative 4 is positive 12 equals 29. And now let's go ahead and combine like terms. So we have 10 plus 12 is 22. 4m minus 3m gives us 1m, and it's positive, so plus m. And it doesn't matter if you have these switched around, m plus 22 is actually the better way to write this. But since we're solving, it's going to end up looking the same anyway because we have to get this m by itself. So now we have a positive 22 to get rid of, so let's subtract 22. Those cancel, and we get positive m equals 29 minus 22 is 7. All right, so this first property is not too bad. Big things to keep in mind: make sure you simplify first, and then just do the opposite of what you see. It'll be the same thing when we get to the multiplication of property of equality, when we start having to divide and multiply. So that's what we'll be taking a look at next time.